some Leetcode practice. So in this video, there are two goals. First goal, solve this problem, put some code here. Second goal is to see how it should behave in a real interview. So let's get started. Remember, the first step in a real interview is always try to understand the problem. If there is anything unclear, please bring up the question, and at the same time think about some edge cases that can potentially break the general algorithm. So let's see. The lowest common ancestor of a binary tree is 3. So given two nodes of a binary tree P and Q return their lowest common ancestor LCA, so each node will have a reference to its parent node. So the definition of the node is below. According to the definition of LCA, the lowest common ancestor of two nodes P and Q in the tree T is the lowest node that has both P and Q as descendants, where we allow a node to be a descendant of itself. Okay, so let's take a look at this. For this tree, for the 5 and 1, LCA is 3. For 5 and 4, LCA is 5. Okay, makes sense. So let's see some constraints. So the tree contains, so the nodes in the tree is between 2 to 100k. That's fair. So it's not an empty tree, and for sure, larger or equal to 2 nodes within the tree. And the node value is within -1 billion to 1 billion, and all node value are unique. So P is now equal to Q, so P and Q exist in the tree. Okay, so it seems like there is no such edge case we need to think about, because the constraints are pretty strict. So the next step is about finding solution. So how to solve this problem? So since it says that the parent node is available, so what we could do is we could just go through. So for the P, we are going to store all of its ancestors. So for example, let's say P is 4, this node here. So we are going to store 4, 2, 5, and 3 into our hash set. And then when we try to find the LCA for P and Q, we are going to start from node Q and go upwards. So the first time we encounter a node that exists in the hash set, then it is the node we pretty much we are going to return as the LCA. So having said that, the runtime is going to be linear to the height of the tree. So the next step, let's do some coding. So for coding, we care about the correctness, the readability, and also the speed. So let's see. First of all, we need to have a set which contains a node. So the node would be, let's say the P parents or P ancestors as new hash set. So P is not equal to a non-pointer, then we are going to have P ancestor dot add P, and P is equal to P dot parent. Alright, and the Q is not equal to a non-pointer, then if the P ancestor dot contains Q, then we're just going to return Q, and Q is equal to Q dot parent, and Q is equal to Q dot parent. Finally, we can just put the placeholder as return none here. So let's see. For example, after we are done with coding, it's time for us to do some testing. So let's start with some sanity check to check the logic using some example test case, and I will explain how this piece of code is gonna work. So let's say P and Q are 5 and 1. So we are going to add 5 and 3 into P ancestor. Then, well, Q is not equal to none. So we start from Q. 1 is not in the set, and then we go to its parent. So 3 is in the set, then we return it. So that's pretty much it about the code. Let's give it a shot. Okay, so it's accepted. Let's give it a submission. Okay, so everything works well for this question, and that's it. If you have any question about the puzzle or about the solution, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.